So you're putting your finger on the wound of macro, which is we have to aggregate, we have to make shortcuts. Okay, welcome to the 15th lecture. This is, there's only 2 left, and you can either be happy about that or sad. Maybe you'll be happy and sad. But in any case, I'd like to push you a bit further in the direction of new Keynesian macro today, and we'll talk about a refinement of the Calvo model that I will present at the beginning of this lecture and already presented last week. And at the end, I'd like to give a few criticisms of the new Keynesian modeling strategy as it stands, and maybe push the argument a little bit that there's improvement to be made, and there are some ideas out there that have contributed to improving the features of the model that, or the predictive ability of the model, the ability of the model to replicate the data that we observe and measure. Okay, so last time we spent a fair amount of time motivating the Rodenberg idea, reviewing it, and then we launched into this Calvo idea. Okay, today I'm going to present this Calvo model in more detail. I'm going to present a micro-founded version of this model, but you'll see in the end that there are still some arbitrary assumptions that are made, and that's the criticism, one of the criticisms that always comes up. But this is pretty much the standard, the gold standard in the profession now for modeling nominal rigidities. Remember, the idea is what happens when a monetary event happens, which in the long run shouldn't affect the real equilibrium. There must be some reason for this disequilibrium, if you like. Some people would prefer not to call it a disequilibrium at all, but to what leads to this lagged adjustment of the economy to the new equilibrium that is supposed to be neutral. And I'll give you more details on that. And if you go on to do more work in this area, you'll be working with this idea. Again, almost everything we derive using the Calvo model can also be motivated using the Rodenberg model. So that's why I put them on equal footing. Both have advantages and disadvantages. Both of them will lead to a supply curve of the economy, which I call the new Keynesian Phillips curve. It's also called that in much of the literature. It's actually a supply curve. We won't be looking at unemployment in this course directly. If you like that, take my search and matching course that I offer next semester, or take other courses on labor economics, or take another course on macro that gives you more connection between output gap and the unemployment rate. Those are all very important questions, but in a course limited to 16 lectures, we have to stop at some point. So I call this a new Keynesian Phillips curve, but it's really like an aggregate supply curve. It's a new Keynesian supply curve. And you'll see that both the Rodenberg and the Calvo approach give us a nice conclusion that you need both real and nominal rigidities to make monetary policy demand shifts have persistent effects on output. And that's has serious micro foundations, this idea. It's been around for maybe 20 years now, going back to the work of Olivier Jeanne and Greg Mankiw and Larry Ball. So this is an idea that still lives with us today. We need to keep thinking about it. In other words, there have to be reasons that the economy doesn't change nominal prices very quickly. In the aggregate, there also have to be reasons why the economy responds to the real incentives that are given cause to observe because of this nominal rigidity. So it's not just the nominal rigidity that matters, it's also the response of quantities to small changes in real incentives that also matter. Then I'd like to finish talking about the new Keynesian Phillips curve in a critical mode. So as you know, economics is an exciting area, but it's also exciting. It's exciting because we deal with exciting topics. It's also exciting because people get excited about it, and often slightly ideological. They let their sort of their belief sets influence the type of models they work on. And you'd naturally think that people who favor government intervention might naturally be gravitating to a new Keynesian approach because it it's the model that gives rise to a framework that admits such effects. And if you believe the government causes trouble and doesn't have any net effect anyway, you'd be more likely to, if you let your beliefs guide you, be attached to the new classical approach, the RBC approach. And I think it's a shame to think in those terms, and some of the most important colleagues that we have are those who have transcended these belief sets and actually, in a very objective way, try to find out the truth, which is, how does the economy really work? The positive and not the normative. Okay. And I'd like to give a possible proposal for, and this is coming out of the textbook, Benassi's book, and I'll give that reading to you also on the line. And then we'll lead into the last lecture, which is next week, and then we'll be finished. Okay? So last time we looked at money in going back to last year, the end of the last calendar year, when we talked about the Kagan model and hyperinflation, when prices are perfectly flexible, prices are forward-looking or jumping variable. Interesting way of thinking about it. But in fact, in the real world, from month to month, from quarter to quarter, there seems to be a lot of stickiness in the aggregate price level at inflation rates that we observe today. So if you go to Venezuela, there's no question that prices are not sticky. You know, they're not sticky, and they're not sticky probably in Turkey right now. Okay, but if you come to an OECD country where the average inflation ranges between 0 and 5 or even 10%, you still get the impression that prices are sort of a backward-looking, very persistent aggregate variable, almost like a state variable. So the question how to model that gives rise to models that induce stickiness, that induce, for whatever reason, people to not to change prices all the time or change them in very small steps. And we talked about that. We talked about the microeconomic basics. The ultimate idea is that firms set prices. So this is a very important point. You should really remember this. Will probably be an exam question. Firms set prices is the ultimate basis for these modeling strategies. If we have a Walrasian auctioneer that's just, you know, with an abstract process that determines a market clearing price, like in the price for wheat or oil, you're not going to be able to get this kind of result. You need to have some reason why the prices are being determined by individual agents who are trying to maximize some objective function, trying to maximize profits, for example. Okay? So we had this picture. I'll show it to you again for review. Another interesting, important linkage to microeconomics. The profit maximization problem for a representative firm with market power is different from one that is a price taker and sets price equal marginal cost. Okay, because you know if you're a price taker, you just set output to the point where the marginal cost of producing output is equal to the price. That's the best you can do. Maybe you're making profits, maybe you're not. Okay, but if you have the ability to set prices, the world changes dramatically. So we really need to think about Joan Robinson, Imperfect Competition, and all the people that wrote after her on this setup. And we have two different ideas. Once you've decided that firms set prices, then what's keeping them from setting the right price in terms of the monetary unit? Because just because you're a monopolist doesn't mean you have sticky prices. Okay, that's a really important point. And therefore, we have to combine this reason for not changing your price that you're setting all the time in the money unit, as well as some reason to deviate away from the level of the price that you could, even if you had no, rigidity at the nominal level. Why would you take your time in getting there? So this picture motivates that very clearly, I think. You have the classic sort of micro one firm setting price at the point where marginal revenue equals marginal cost. Okay, so remember, if the firms have no market power, then the price is marginal revenue. If you sell an extra unit, you just get the price. But as soon as you can influence the price by restricting quantity, by not selling as much as you could, then you'll basically have an effect on the price. And an optimizing firm would choose the intersection of marginal cost and marginal revenue, okay? And the induced price would give us P star. And the question is, under these conditions, what would happen if the firm setting prices in the monetary unit, in nominal terms, would experience a shift outward of demand to D prime? Okay, and I tried to motivate that there might be conditions under which a firm would not change its price, retain its price, or keep its price at P bar, which was the old P star, instead of moving to a new P star implied by the second panel in this diagram. And the notion is that just expanding output at the old price that was optimal under the old conditions would still yield extra profit. Okay, it would still yield good bucks for the firm, but it wouldn't be the very best the firm could do. By construction, the new P star would be the best the firm can do. Okay, so the firm has to sort of say, well, and this is the whole point, what's the comparison? If I keep price at P bar, I'm actually foregoing profits. I'm actually producing some units at a marginal cost that exceeds the marginal revenue. And if you integrate those two areas, or integrate the one under the marginal cost curve and subtract the one under the marginal revenue curve, that red triangle is exactly the cost of not going to the right place. Okay, but it's still profitable for the firm to do so. And there might be something keeping the firm from moving to the new P star because there's Rodenberg costs of moving quickly, that we did that last time. And now I'm going to talk about just not being able to do it. Okay, so this would be the Calvo idea. The idea is that you're just distracted, or there's this magical fairy that comes and gives you the blessing or the tap on the head, and you can change your prices, but only randomly and only according to some sort of process over time. Okay, so those are the two. You're probably still thinking this is crazy. Actually, it's an extremely effective way of doing this. It's also giving us closed form solutions. All right, so for an analytic perspective, this is a nice way to move forward. Okay, so I'm going to follow Robert's, and I urge you to look at this paper, and I matched the notation. And if those of you are adventurous, you can read Galley's chapter 3. It's the cornerstone of his book that Lutz Weinke uses extensively in his courses on advanced macroeconomics. Okay, and this book is available online. It's a great gift of Jordi Galley to us. Okay, so I'll come to his, because what he does in his book is he gives us the complete derivation of why a firm in a micro-founded world would have a downward sloping demand curve. Okay, and it's a modeling trick, a facility that helps us move forward. Okay, recall that the last lecture and the one before that we talked about Rodenberg. Firms can change prices anytime they want in the nominal unit, in the monetary unit. So they're not constrained by some magical fairy. They're basically free to do what they want. And all firms are the same. So the optimal policy of any firm in the set of firms will be the same. So the disadvantage of the Rodenberg model is you have a single price. Okay, because in equilibrium, firms are competing with each other, and they're all identical, so you'll have an equilibrium where prices are identical. So you don't get any price dispersion in that model. So those who like the Calvo will say, firms can't set prices whenever they want. You'll observe a distribution of prices. Okay, and we can actually get an analytical expression for that. I'm not going to ask you to do that on the exam, but it's a really important idea. The Rodenberg model doesn't give us a variance of the price level, and I'll show you later that indeed there is a lot of variance. In Germany, in the United States, prices do not move together lockstep. Okay? They're spread out over time, and also in terms of the level, there is a clear distribution of changes at any point in time. Okay? So in the Calvo model, we're going to try to pick up on that. So using a certain amount of arbitrariness in one dimension, we're going to actually generate some very interesting stuff in the other dimension, other interesting variation. And as I said last time, motivating firms can change prices when they're sort of able to do so. Okay, so you can think of just being distracted. It's a nice alternative to thinking about the ferry. You're getting a telephone call, and when you get the telephone call, you can't optimize your price, so you're just kind of distracted. And then when you put the phone down, you re-optimize your price, knowing that in the future you might get distracted again. Okay, so that's an alternative way of thinking about this. It's not a statement about information that you've gathered, because you can gather the information continuously. Okay, so that's a very important point. In the Calvo model, firms, when they get to set their price, have complete information at their disposal. There's no confusion. Now, there's an alternative we'll talk about later where you can change that as well. So if in a discrete time model, we have a probability of being allowed to change your price, and it's 1 minus phi, or phi, okay? So phi would be the probability of being rigid or being unable to change, okay? And you can think of this phi as being a little bit like a discount factor. In the end, we'll see how it actually has that effect. Because obviously, if you wait 2 periods, the probability that you will be able to change the probability you'll be rigid in 2 periods is lower than the probability that you will be rigid in 1 period, etc. You'll see that when you look at the formula. So we already showed last time, there's a nice derivation of this, that this is a probability distribution. Okay, so if the probability of not being able to change your price is phi in period 1, then the probability of changing it in period 2 is 1 minus phi times phi. Okay, and you can extend that to infinity. And the crazy thing about the Calvo model is that there are some firms by construction that will wait a long time. It's just a bad draw. Okay, so think about that Italian barber we looked at last week. Do you remember the Italian barber? Changed his price once the whole year. So in the Calvo framework, that would be a very low probability of being able to change a price in any given quarter. Okay. On the other hand, you have the fruit stand in the same Italian village is changing her price every day. Okay, because he's getting new shipments and she's competing with lots of others. I mean, there's lots of stories you can tell in the Calvo model. The story is not so important. So this is a probability distribution. And I showed that just by taking the sum and rearranging. So it's something you should be able to do also as an economist. You should be able to do this formula in your sleep. Okay, it's a very nice formula. The Calvo's genius using the Poisson approach, or the exponential distribution of times between price changes, is not his invention. A lot of other people have used this in a lot of other models. Any sort of model with a friction. Okay, so if you take my course in search and matching, it's exactly the same thing. The probability of getting a job offer every period, and the probability of not getting a job offer in a period. Okay? Okay, so we can also derive the expected time between price changes. We did that last time. Here's a repeat. Okay, if phi is the probability of not being able to change in a quarter, then 1 over 1 minus phi is the duration, the expected duration. Okay, so you can see that as phi goes as it goes to infinity, the expected time between price changes is going to get. So what have I done wrong here? No, sorry. As phi goes to infinity, as phi goes to 1, the expected time between time changes goes to infinity, and as phi goes to 0, the expected time between price changes goes to 1. So that's perfectly okay. Remember, phi is a probability, so it has to lie on the interval between 0 and 1, and we sort of force it to be in an open interval. Okay, so let's play with this model a little bit more. This degree of rigidity is an important parameter, and we'll see how it actually affects the model's dynamics. It will affect the aggregate supply curve's slope in the end when we derive it. Okay, so the calibration of the model will, of course, be dependent on the value you choose for phi. So in a quarterly model, 0.8 would lead to an expected duration of a price contract to be 5 quarters. That's a long time. Now, a lot of times, this Calvo idea has been used in labor to model wage rigidity. And we're not going to do that in this course, but you can actually think of nominal wages set by unions in a contract mode, or a monopolistic labor union, which is a bit unrealistic, but you can also think of one that has a high elasticity of demand that it's dealing with, could be a good stand-in for a wage rigidity situation. And then you'd have something very similar in Germany. We know that unions renegotiate their contracts on average about every 2 years now. In the 1970s, it was a year. So you can actually use that to calibrate a wage setting variation of this model with nominal wages being set by some process like this. And of course, the higher phi is, the longer the duration is. Okay, and it also depends on the way you set up the model. If it's a monthly probability, monthly calibration, or if it's annual, or if it's quarterly, it makes a big difference for the dynamics. That should be pretty obvious. Okay, so now we're going to think hard about what the price is in this Roberts implementation of the Calvo model. Now, this is an easy way of doing what other courses do in much more math and derivation. So we're basically gonna have to make an assumption here. We know that if firms are doing the full-blown maximization, they're going to choose a price when they're allowed to that will maximize profits going forward, knowing well that they may be in a rigid price-setting mode for a long time. Okay, so we already saw that if phi is 0.9, that means that for many quarters, the firm is going to be stuck. So the firm better do it right. The firm is going to set a P star that's going to be forward-looking, and it's going to anticipate demand in the future to make its profits as large as possible today, because it knows that it won't be able to change prices until the ferry comes again. Okay? So in a sense, that's why I said this phi is like a discount parameter. And this is a shortcut to that optimality result that you would derive in sort of an advanced course in monetary economics. Okay, it's going to say basically that P star is the firm's choice of price when it's allowed to choose, and that's going to be basically a weighted average going forward of P star of all the future periods, because the firm is cognizant of the fact that it may not be able to change for a long time, so it's going to have to look forward and ask, okay, well, if I'm allowed to change only in 10 quarters, what is that price I'm going to be choosing? So I'm going to try to front load. The idea is to front load. You set the price kind of anticipating more than you would if you were able to change your price with complete ease anytime you wanted. Okay, so this is, a lot of people see this as an advantage of the Calvo model. Some people see it as a disadvantage because it implies that firms are kind of obsessed with making sure they don't miss the boat in the future. So if they see a boom coming in 2 years, they're going to set their price today that recognizes that even though they might not get stuck, but if they do get stuck, they better be doing the right thing in 2 years' time. Okay? So the P stars of the future, the optimal prices the firms would use their monopolistic competition if they had free reign to set prices, will be impacted into the current price level. Okay, so you have a moving forward average of expectations. Now look carefully at that expression. It says the expectations at time t, because I'm stuck in time t, I don't know the future. I don't know the future PT star t plus tau, but I'm going to try to guess what it is using the best information I can. So I'm going to use, under the rational expectations, a conditional expectation. Okay, so it turns out you can rewrite, if that's true going forward, not just today but also to tomorrow, you can rewrite the expression as the optimal price today plus the expected value of future prices that are optimal after period t. Okay, and remember this is an assumption. Okay, so it's assuming basically the price looking forward is going to be this weighted average, and you can manipulate that, and this is one of the most interesting parts of this model. You can manipulate that expression to get the last expression, which says that it's a simple weighted average of two parts. One is the optimal price if I were allowed to change today, plus the price level that I expect tomorrow. Okay, and that price level tomorrow is simply from the first line, once leaded weighted average of future optimal prices. Okay, so if this is kind of going a little bit too fast for you, just go back and read this Roberts article, and he goes into excruciating detail about this. But it's simply just manipulating a recursive relationship. Okay, so that formula will help us go very far, because we're basically we're still remembering that P star is your optimal price, which depends on what the other guys are doing, and I haven't talked about the other guys, okay, and then what aggregate demand is doing, and what the shock might be doing. Okay, so your P star is a three-pronged object. It depends on the competition, and it depends on aggregate demand, and it depends on a potential supply shock. And we usually make an assumption that the expectation of E of epsilon is equal to 0 going forward. So you don't, unless you have a magic crystal ball, you're not going to know that there's an oil price shock. But when it occurs, it will affect you immediately in period T. Okay? Now, if a firm doesn't get to change its price, it's going to charge its old price. So the world is going to be a mixture of those firms that have the good luck of being tapped by the Calvo ferry with probability 1 minus phi, and all those other loser firms that are stuck with probability phi at whatever price they had in the past. Okay, and remember, this doesn't have to be a single price, because that's the cool thing about Calvo. You have a whole distribution of good and bad luck going backwards. So Calvo's genius was basically to exploit that moving average, that last expression. So again, the average price for all the players in this economy that have or have not been able to change their price in the past or are still stuck in the present will be a mixture. It will be also a weighted average using this simple linear geometric weight scheme. Okay, what defines the price index? You're going to define that price index as the now going backward of all the firms that have basically set their price at some period in the past t minus tau and are stuck today. Okay, so this is a backward-looking index. Okay, and using the same rewriting trick, I can rewrite that as 1 minus phi times the optimal price today that I would set if I were allowed to set, plus all the baggage that I would have had coming into period PT, not being able to change. Okay, so again, the geometric weighting scheme, the Poisson distribution assumption for the ability, or the exponential distribution on times between changes, gives rise to the same logic that we had before looking forward, the front loading of prices, P, and now we have P prime is what the other guys have done in this economy, and that's going to be an average of those who are able to change today plus those who are stuck. So we've moved basically from an individual pricing decision to an aggregate. And once you've got the aggregate, then we can compute the inflation rate. Okay, then we've got a supply curve. We've got a supply curve because we know P star depends on Y, because Y is the aggregate demand of the economy. It depends on what the other guys are doing. That's P prime. Those are going to be the same. So we can eliminate that. And then all we've got left is we can derive the inflation rate. Okay? So I'm just going to show you the inflation rate, and I'm going to give you a slide that derives every gruesome step. It's just algebra. Okay? And again, like I said, if you think this is nasty, if you do it the full-blown optimization approach, it's even worse. So this is just to get you going, to get you in the mood for looking at this type of this model. Remember, inflation rate is the change of the aggregate price level. So, and we're in logs, so the change in little p is going to be the inflation rate. Okay? Inflation rate 1 minus, PT divided by PT minus 1 with big P's minus 1. Okay, that's going to be the inflation rate. It's the first difference of P prime, and that's just equal to, and I'm going to show you how we get to that conclusion, it's equal to the expectation of inflation in the next period, conditioned on period T information. That's the forward-looking part of the Phillips curve. That's like the, if you like, the core inflation part where expectations are embedded. The second term is aggregate demand. Now it's a linear combination, it's a linear with linear weighting, and the weight is related to this Calvo parameter. Okay, so it's 1 minus phi squared divided by phi. So you can see as phi gets really, really small, that coefficient is going to get really big, and the Phillips curve is going to be really steep, or the aggregate supply curve is going to be almost vertical. Okay, whereas if phi is getting close to 1, if I'm very likely to be stuck as an individual, then the economy is very likely to be stuck, and therefore the Phillips curve is going to be flat. Okay, so that would be the case of phi going towards 1, excluding the endpoints. Okay, so we've already got some nice intuition here. The last part is the supply shock, and it has the same logic. So if in period T we have a big oil price increase that gets rammed right into the cost structure of the firm, that's going to get passed on right away, depending on whether the firm can do it or not. So a firm could face this cost shock and still not be able to pass it on, which would be very bad for firms' profits. Okay, so if you're in a contract and you're selling bread at 50 cents a loaf and the price of all your materials doubles, you're in trouble. And you can't change the price by assumption, the Calvo assumption. So, a lot of people say, well, that's crazy, man. I could just shut the business, just shut down. Okay, so there's a lot of critiques we can, but again, this is a nice tractable way of getting what we call the new Keynesian Phillips curve. I already did it last week with the Rodenberg model. Okay, so now we've got two different competing variations on price rigidity in terms of the monetary unit, which gives rise to a Phillips curve or a supply curve, if you like. Okay, again, most people would prefer to call this a supply curve, but in the Roberts reading, he calls it a Phillips curve. So again, don't worry about that too much. This is the Calvo version. Okay, so I've got a slide here that gives you some details on how this is done. It's just mechanical. Okay, you have to understand, P is the individual firm's preferred price. Or the P prime is the price of what all the other ones are doing. And therefore, you do the substitutions, you get, and you have to do one interesting manipulation here, which I've highlighted, which means you have to lead and take an expectation of that. Okay, which is nothing really super fancy. You have to rewrite PT plus 1 and then take expectations of it, as you can see in line 5. Okay, so that's how you get the Calvo new Keynesian Phillips curve. Now, as I said, if you do this with brute force using the profit maximization, and we've done a shortcut. We've basically said we know what the firm's optimal price is if the firm were free to choose, and then we get this front-loading result, which says the firm, period by period, has a certain preferred price, but it knows that it may get stuck, so the firm front loads. Okay, so that's a really important part of the Calvo idea. Firms, if they see something, if they see clouds on the horizon, inflation's coming, they start raising their prices now. Okay, so a lot of people find that problematic too. So there are lots of tensions. Now I'm going to give you some more details on Calvo, the full-blown version. I'm not going to take you through all the derivation, but I want you to know where this demand curve comes from. That's important. Okay, so it's a little bit of microeconomics, and it follows Galley in chapter 3. All right, so the idea is, I've already told you, I've drawn the picture, and then I've given you the optimal price. The question is, where does this demand curve come from? It actually has to come from first principles. It should come from utility maximization. It should come from you choosing product A or product B. And in the Galley setup, there's an infinity of different products. So we have an interval between 0 and 1 indexing all the products. So it's very tractable. It's nice, but you could also do it with N. But you might say, well, where does N come from? Where does the number of products come from? Well, in this one, we're just going to have, basically, people have utility over goods. They have utility over variety. They like the variety. They don't just, have Chinese food every day. They'll have a little bit of Chinese food today, and they'll have some Vietnamese food tomorrow, and they'll have some Turkish food, and then they'll go back to a good old German. All right, so people have a preference over variety. And that gives the firms selling the respective types of food market power. Okay? So we're going to assume, this is important for you if you do micro, for example. It's a very nice setup. It's also important if you do labor. So I want you to kind of pay attention now. This is important. So remember before we had this representative agent maximizing utility. Now we're going to get fancy and we're going to say that CT is an index of a lot of little tiny goods, and each one of those little tiny goods is being pushed by a firm. Okay, so that's the trick that macroeconomists have developed to get this price stickiness to make sense. Okay, so we're going to keep the old requirements, the old assumptions. The utility function, like everything else we've done, has first derivative is positive, second derivative is negative. The worker has disutility over labor, L, and that disutility is increasing with the work time, and L is bounded by 1 and 0. And CT is this monster. Okay? So this is the new part. This is like a CES index or a Armington aggregator. And if you don't like integrals, just think of a summation and just cross your eyes a little bit. It looks like an integral. Okay, it just means there are a lot of goods. And we're going to index every good between 0 and 1. So I equals 0.3 could be soccer balls. And I equals 0.7 could be trips on the S-Bahn. Okay, so the I is indexing the good. And then your utility that you get from this basket, this bundle, is aggregated using this formula. This formula has some very special properties we'll get to. Okay, one of them is obviously related to the value that you get from variety. Okay, and under certain conditions, you really care about it so much that if you don't get a little bit of everything, you're going to be really upset. Okay, but most people seem to have some substitutability. If you can't get oranges, you'll eat apples, and that sort of thing. And we're treating all the goods the same, just for the sake of abstraction. But if you wanted to, you could make it much more complicated. Okay, so this is a symmetric CES aggregator. Okay, Galley calls this a subutility, or it's a CES subutility function. It's also been called other things. Okay, that object can be differentiated. It's just a sum. Think of it as an integral as a sum. Okay, and there should be a di. It's missing. I'll fix it. Okay, there should be a di right there. Okay, so this epsilon is an important parameter. That's going to determine basically the substitutability across products. Okay, so if you look at that really carefully, you can see that as epsilon goes to infinity, we're going to make epsilon live between 1 and infinity. So when epsilon is just a little bit greater than 1, then people really like to have everything in their basket, even if it's really expensive. So even if bubblegum costs 100 euros, you're going to buy a little bit of it. Okay? On the other hand, if epsilon is really high, like 10 or 200, then goods are basically very substitutable. Right? So you go for what's cheap, and you just load up on it. So that's going to capture all the different possibilities, right? If we can let that epsilon vary, then we can effectively it's going to be like the elasticity of demand for the representative good. Okay, and we look at products out there. We know that firms have market power, but they can't get away with murder. And this is kind of what we're going to be doing. This is going to give us the slope, and I'm going to derive that for you because this is a really useful trick in our tool bag or toolbox of tricks. You can use this for all sorts of stuff. You can use it in public finance. You can use it in industrial organization. Okay, this aggregator trick. Okay, so look at the properties, and I'll answer your question in a second. It's a homothetic function. Okay, so if prices are, when you're maximizing utility with respect to that baby, if you basically increase income, there will be no bias towards one product or the other. So we speak of homothetic utility. Okay, it has like constant returns to scale. Okay, so getting a little, if you double everything, you're going to get double the utility from this subutility function. And of course, that subutility still goes into U, and you're going to have decreasing marginal utility for this bundle. But we've separated the bundle from the intertemporal part. Okay, so we have a two-stage approach. That's really the trick involved. Okay, now again, as I said already, as epsilon goes to 1, the thing gets really kind of weird. People really want to have a little bit of everything, even if it's really expensive. So I want a little diamond dust and if I don't get that diamond dust, I'm going to be very upset. I'm willing to pay, even for just micrograms of it, I'm going to pay something for it. In fact, in that case, the share is going to be constant. It's a little bit like a Cobb-Douglas type of setup. Okay, so it doesn't capture all the types of behavior we have, but it captures probably the most interesting stuff. As we move epsilon towards infinity, the goods are kind of apples, oranges, Chinese food. I eat everything. It doesn't matter. Okay. Again, this is just trying to capture because the firm's market power is going to be captured by epsilon, and that's an important power. That's going to actually tell us how much the firms can mark up on marginal cost. If you remember from your micro, that's called market power. And like Amazon, they have a really low epsilon. I mean, they have lots of market power. But if you're like a fruit seller at the market, you change your price, you're not going to get any business. That's the point. You had a question?
Yeah, you kind of answered it already, but
Absolutely. So you're putting your finger on the wound of macro, which is we have to aggregate, we have to make shortcuts. And we think those things are maybe second or third order important. So if Germany just produced bananas, and then we had to import everything else, we probably would care a bit more. But we know that Germany produces a lot of stuff. And Germany also imports stuff. So, I mean, once you're getting into, so I have a PhD student who's actually got the imports down. So she has a model where they're importing, it's another CES aggregator. And that's the bananas and the oranges and the Blutorange and whatever else you're importing from the southern part of Europe, and then the exports are a different bundle. But again, the devil's in the detail. And as soon as you start saying, well, I want to have a little epsilon for these guys and another different epsilon, then you have to track that. And we're trying to get away with as much as we can just to capture what we see in the inflation rates. So we'll come back to you maybe at the end. I criticize this because it's not. You saw it last time. We showed last time that there are some firms that change their prices all the time, right? And there's some that never change their prices. That means they have different Calvo parameters. Okay, they probably also have different elasticities of demand. So there's all sorts of fancy stuff you can, but just get through this first, and then we'll push a bit harder later. So the consumer has a two-stage decision. First, the consumer looks right and left and says, okay, I've got this intra-temporal decision, how much of the apples and how much of the Chinese food, how much of the Korean kimchi, whatever it's called, and then I decide, given this basket, how am I going to trade off the basket today versus tomorrow, which means saving? How much am I going to not consume? How much am I going to put in the bank? How much am I going to invest in capital? Okay, so that's the logic of this is to have a two-stage decision, and we'll solve the first stage first, and then the second stage you already know how to do. We've already done it. We've done the macro part. But I think you should see this because it's kind of cute, and it tells you something about how important this differentiation of product is. Okay, so within the firms, each firm produces one of these goods in a monopolistic competitive way, and I'm going to use the index I, as I always have, to index the goods. So CI is the choice of bananas or iPhone. Okay, so one of these goods is we're considering given all the other prices. So PJ is the price of all the other goods on the interval J from 0 to 1, and this is a closed interval because it's just an address. It's just a name. So 0 could be rent, your rent of your apartment, and 1 could be the price of gasoline. I don't know, whatever you like. It's just an abstraction. So here's the thing. I'm going to say, suppose the consumer has Z income. How's the consumer going to allocate its income across these goods, this large number of goods? And I'm going to start with I. Okay. So you're just maximizing this index value given your budget constraint. The budget constraint says I can't spend more than I have, and I have Z. Okay, so it's just the integral of PI times CI over all the I. Just think of it as a sum. It's like going to the cash register and you have a Kassenbon. You see all the stuff you bought, how much you paid and per good, and how many goods you bought. Okay? So, that's just like a sum. That integral is just a fancy way of saying a sum. So it's just summing up all the little tiny pieces, all the little micro goods that you're buying, and you're paying P in terms of the nominal unit, and you have Z income in terms of the nominal unit. Okay? So now it's starting to sound like reality a little bit. Okay? So we can use microeconomics to figure that problem out. We can write down a Lagrangian because you can't spend more than Z in every period. And the consumers don't, when they do this two-step problem, they don't think about the future. They're just thinking about it right now because they don't have a different intertemporal substitution for bananas versus olives versus Döner, right? It's all the same. It's been packed into this aggregator, so it's easy to do this. Again, you're all smart. You're all masters. You should handle this stuff. I mean, it's easy, okay? It really is. It's just a fancy way of writing it down. There's the utility function, the sub-utility function for the period. And the second part is the capturing of the Lagrange issue. The idea is you can't spend more than you have. You have Z, the consumer gets Z. I'm not going to tell you where he gets Z from. We know where he gets it from. He has to work, or she has to work. She may have some wealth. Okay, but we can divide those two into two separate bits. Okay, so the first order condition is just easy. The differentiation with respect to CI just means you pick out of that integral the value of I that you're varying, everything else is constant, and then they got the budget constraint. You can only vary one part of that. So the first order condition is just a piece of cake. It looks just like micro 1. Okay, it looks a little bit complicated because I haven't simplified it yet. But on the left-hand side, we have marginal utility. And on the right-hand side, we have marginal cost in terms of utility. Because you have to pay P for an extra good, you have to pay PI, and the value of the resources, Z, that you're paying, is going to have the interpretation of lambda, the relaxation of the constraint. So we can use the definition of C to get rid of that. Look how beautiful it looks now. If I just use the definition of C, the aggregator, and just plug it in, because I know what it is, I get that. That says that the ratio of CI to the aggregate is going to stand in relationship to lambda, the Lagrange multiplier times the price, related by 1 divided by epsilon. Epsilon is the elasticity of demand. I'm going to show you in a second. I'm just going to simplify that. We're going to get a demand curve. We're almost there. We just haven't gotten rid of lambda yet. So formally, lambda, I don't know your lambda, you don't know my lambda, but I know your income. Your income is Z. So the trick is, how do you eliminate lambda? Who wants to tell me? Right. Excellent. Excellent. Use the budget constraint. Okay? And I'm going to show you two different ways of doing it. So when you go back and look at your slides later, you're going to see there are two. Galley does it one way, which I find it a bit hard to follow in his appendix. I don't want to criticize Galley's appendix, and he's much more famous than I am. But he could have done a better job explaining it. But it's in the appendix. So who reads the appendix? You read the appendix. You have to read it. Okay? So I do this two different ways. One is to plug it in directly into the budget constraint, and the other is to do the Galley trick. Okay? The idea is still getting rid of lambda. You got, because no one knows what your lambda looks like. I'll never see your lambda, but I can see your income, and I can see the prices you face. If you're doing the right thing, that's enough. So rewrite that first order condition like this, pre-multiply it by the price of the ith good, and then basically take the integral over all the I. And we know that's equal to Z. All right? So on the left-hand side, we've got Z, and on the right-hand side, we've got this monster, but the monster has lambda in it, so I can factor lambda out, which is a constant. I can pull it out of the integral, and I can solve for lambda. And then I'm done. Because once I get lambda, I can plug it into the first order condition, and I've got a demand curve in terms of income and prices, which is what I want. Okay? So we just plug it in, solve for lambda, and there it is. There's lambda. Still looks kind of monstrous, doesn't it? The integral over the prices is kind of like a price index. In fact, I'm going to define a price index that is exactly a function of that integral. That's going to be the CES price index that corresponds to utility under the aggregator I assumed. Okay? So I told you this would be fun. You just take that lambda, substitute into the single first order condition for the ith good, or for any good, J, and you get the following result. Okay, and all I've done here is if you look carefully at this, you see that the integral, you've got this thing raised to the power of minus epsilon. So if you raise something to the power of 1 divided by epsilon to the power of epsilon, epsilon disappears. Okay, so I hope you can handle that algebra. It's not that hard. But that's what it simplifies to. And then I just rearrange it, defining the CES price index as an integral function of the PIs. Okay, this is what we call a CES price index. And that price index has the same homogeneity of degree 1 that the function has. So if I double all prices, the price level doubles. That's what we want. It's the way price indexes work. Now, most of you don't even know what a price index looks like. I'm going to show you some price indexes in a second, okay? Most of us use geometric averages or linear averages, okay? But in some sense, this CES price index can capture a lot of that type of assumption. There's a whole, Irving Fisher, a long time ago, was involved in trying to figure out what is the right price index. It's an interesting discussion. It's also very relevant for macro. Okay, so I define that price index, and then I'm done. Okay, I can basically rewrite the demand curve like that. So for any good J, so forget I, doesn't matter, I, J, K, whatever. For the jth good, you see that it's basically a function of two things. It's a function of the relative price of the jth good with respect to the aggregate price level. So it's the real price. And it's also a function of your real income, which is Z divided by the price index. Okay, which makes perfect sense to me. That's what I learned when I was an undergraduate. Okay, this is the kind of demand curve that Galley and his students have worked with for the past 25 years. 20 years. Okay? This demand function has unit elasticity with respect to real income. Okay, so that's interesting. Homotheticity gives us that property. So if I double your real income, you're going to buy double of everything else, all the goods, holding prices constant. Okay, just an expansion path. So all the goods are kind of, they have unit linear angle curves, okay, if you like. Okay, the second thing is its price elasticity is exactly epsilon. I've cooked it to do that. The whole brilliance of Galley was making the exponent in that CES aggregator just come out so you get the elasticity of demand for the good. And that makes sense to me, okay? So if epsilon is really, really high, we have a very elastic demand. Small change in price means very, very sharp reduction in demand and very little market power. And if epsilon is really close to 1, then firms have lots of market power. Firms won't price optimally in a place in the demand curve where the elasticity of demand is less than 1. So we just rule out that, and the model rules it out for us. Okay. Finally, this function is homogeneous of degree 0 in all prices. So if I double all the prices, including the price of good J, nothing happens. It's a wash. If I double your income, I double your nominal prices. Everything that's nominal gets doubled. Nothing happens to CJ. Okay? So that's a nice property too. People don't have any money illusion. Okay, so this is the demand curve faced by the representative price setter in the Calvo model, either in the full-blown version that you won't see in this course or the baby version that I presented according to Roberts. Okay, so this is an important building block. I'd like to give you the Galley version in case some of you are adventurous enough to download the chapter and look at his appendix. Okay, and the appendix should be extensive, but no more extensive than necessary. Otherwise, you have like huge books. So his idea is to make it very efficient. Okay, so what he does, he takes the ratio of the first order conditions. If you take the ratio of those first order conditions for any good I and J, the lambda cancels. So he kills lambda from the very start. He doesn't do the fancy integration and solving for lambda. Okay, so that's what he does in his appendix. This is kind of interesting too. It says intuitively, if I take the ratio of the demand for bananas and divide it by the ratio to the demand for egg rolls, spring rolls, it's going to be a function of the price, the relative price of those two things. Okay, so and that relative effect will be depending on the elasticity of demand. Okay, so if you take that, you can plug that into the budget constraint, and you still have to integrate. You still get something that looks like this, but you don't have lambda anymore. Okay, so you can just solve by simplifying, and you get you have to take that same step of defining the CES price index and apply it to the first expression to get that expression, which can be rewritten as the one we had before. Okay, so it's the same outcome. There's no difference doing it both ways, okay? So this detour, I claim, is very important for you, for good master's education. If you want to go do a PhD somewhere, in macro at least, you need to know how to do this. But even in micro, you have to understand one of the nice properties of functions like this, constant elasticity of substitution. Okay, that's why it's called a CES subutility function. This type of aggregation has very interesting properties, very useful in economics in general, and not just in macro. Okay, so both of these approaches have given rise to what Roberts calls a new Keynesian Phillips curve, what I would prefer to call a new Keynesian supply curve, modern new Keynesian supply curve that people use in central banks because it has some interesting properties, right? But it has totally different derivations. The Calvo approach is different from the Rodenberg approach, which we did last week and the week before. In the Rodenberg setup, you're free to change prices anytime you like, but you don't want to go too fast. In the Calvo version, you'd like to go fast. You'd like to go wherever you want to go, but you're impeded by some nuisance, some fairy, some magic spell you're under that you can't change your price, or you're distracted by a phone call or something. Okay? But it produces a link between inflation today and inflation expected tomorrow, as well as output. And if you take that relationship and recursively solve forward, you can actually show that inflation today is a function of expected demand today, tomorrow, into infinity. So the inflation can be recursively eliminated from that Phillips curve. So it's a very, and then the way it's changed, the way it's related is depending on this rigidity parameter. Okay, so, and again, what matters is costs. So if you take this to the next level, you'd look at the marginal cost evolution, which is something we won't spend much time talking about, but you can think of two aspects. One is the markup for the representative firm, which is actually a constant, but the fact that firms are not able to change all the time means that the average markup will be changing over the business cycle. Okay? Good. So maybe I'll give you a little bit of review just to show you how they both relate. So these are two different versions, and if you were here last time, the time before, this is what we did then. Remember I showed you, you've got the same qualitative link between inflation expected tomorrow and inflation observed today. And you've also got this role of aggregate demand today and the cost shock epsilon. And again, remember we took our toy model at the beginning of the year. I tried to show you how you can get dynamics in an economic model by playing with a baby undergraduate ASAD model. But that's exactly what this was. That's the same kind of setup. We've just we've done somersaults to derive a version of this model that looks like this. Okay, so this core inflation kind of corresponds to the expectation of future prices, future inflation. Okay, so that's these models are much more stringent in terms of what they interpret this as being. You've got the effect of aggregate demand on the evolution of inflation currently, and you've got the supply shock. Okay, so that's just kind of holding your hand to reach back and see, well, I've seen this before somewhere. This should remind you. Okay, so here's another very important intuition that I always try to spend some time thinking about. And this follows Roberts. Okay, so it's not enough to have an economy with lots of nominal rigidity. So nominal rigidity in the Rodenberg model would mean a value of C that's high. Remember, C was the cost of changing the price given the price you have now because you aggravate your customers. In the Calvo model, there's no aggravation. You just can't do it, and that would imply a high phi. Okay, so phi and C are kind of substitutable. They have the same kind of role. They come in the denominator in the coefficient that multiplies the log deviation of output from its trend or the output gap. Okay, so when when little y is negative, you're below trend, and there'll be deflationary pressure. And when little y is positive, that means you're above trend, there's inflationary pressure, okay? But that's conditioned by the value of phi in the Calvo model and by Rodenberg by C in the Rodenberg model. And if those values are high, and you can see that it's a little bit, the mechanism's obviously mathematically different because C in the Rodenberg model has no upper bound. It can be very, very high. But the phi in the Calvo model is bounded by 1. But as phi goes to 1, the numerator of that expression goes to 0. So the price level and inflation become very, very sluggish. Okay, so inflation has a mind of its own, basically. Okay, that's one way of thinking how the nominal rigidities matter, but it's all conditioned on B or beta being positive. Okay, so there has to be some linkage between the desired price and the level of output the firm is producing. If the firm doesn't want to produce, even if the relative prices are changing a lot, then you won't see much effect on inflation. Okay, so it's necessary for both B or beta, so B is the Calvo model and beta is the Rodenberg model, and nominal rigidity to be positive to have real effects of monetary policy. Monetary policy will be moving demand around to affect the inflation rate. And that's a necessary condition. Now, there's an intuitive way of understanding this, and I'd like just to think about go back to the profit maximization problem, which we haven't spent a lot of time talking about. I've alluded to it. But if you're doing the right thing, okay, you can think of doing the right thing means choosing the top or the peak of a profit function. All things given, what price should I set to make my profits as big as possible? So again, if you write the profit problem down explicitly, intertemporally, in every period profits will be chosen, all things given, to make profits as high as possible. And that's saying something about the slope of the profit function at the optimum should be 0. That's like saying the first derivative of the profit function is equal to 0. I've maximized my profits. Okay? So this profit function is, it can shift. So what would happen if it shifted? Because the demand curve shifted. And the question is, what do? You were at P star, and now you're thinking, well, should I go to P star prime? Should I change my price? Is it going to be worth it to me? So what do I get out of doing that? Well, obviously, it's going to have to do with two things. How much of the vertical can I actually exploit? Is there a big gain from changing my price? So suppose this profit function were flat. There wouldn't be much gain from changing prices. Even if my prices are perfectly flexible, what's the point? Right? That's one possibility. The other is that it may be very costly. That's the nominal rigidity. To move from P star to P star prime may cost a lot. I may pay outside the profit function implied by static maximization. I might also have to pay. So you can think of two parts. You can think of the price of moving, and you can also think of the gain from moving. And that's exactly what we did before with the diagram, the classic sort of Robinson imperfect competition diagram, that red triangle. It has to be worth it. Okay, so that was an insight of Greg Mankiw's about the micro incentives can lead to macro rigidity. Okay, so that's kind of to summarize the necessity of having both real and nominal rigidities to make this model work. Okay, so now I'd like to spend the last few minutes of the lecture talking about critiques of the new Keynesian Phillips curve, because macroeconomics is exciting because it's exciting material, but it's also exciting because there are lots of fighting going on. People are discussing these things, and there's a fair amount of disagreement about the details. Okay, the big detail would be, are prices rigid or not? I think most people agree that prices appear to have some rigidity. The question is why, and does the Calvo approach or does the McCallum approach, the Rodenberg approach actually do what it's supposed to do to help us understand it? Okay, so one critique of the new Keynesian Phillips curve approach is that we don't want policy to have a persistent effect on the natural level of output. Okay, so McCallum has criticized these models because, again, I'm not going to show you this in detail, but if you're interested, I can give you the references. Some of the references are in the readings. It means basically that policy should not be able to exploit and defeat the natural rate of output, the natural rate of unemployment, or push the economy persistently beyond its production possibilities. Okay, so in other words, we really want to impose on this model the property of long-run monetary neutrality, but also that even though people are being fooled, it shouldn't be possible to fool them in a predictable way. Okay, so people can get behind the policy that's giving rise to this shift in aggregate demand, they may be able to defeat this policy. So that's the McCallum critique, and it puts a restriction on the models that we are able to look at. And if you go back and look at if you look carefully at these two equations, you might be concerned about the possibility, when you combine that with an aggregate demand side, of an economy of being persistently, through a policy choice, being able to move the economy away from its natural level of output, because people would try to anticipate that. It's a little bit like the Lucas critique, but it's like the next level of the Lucas critique, which I'm going to come to. Okay, so the other critique of the new Keynesian model is it doesn't really give us enough inflation persistence. So remember the expression for the inflation rate that's implied by firms that are setting prices knowing that they may get stuck. Okay, that's the Calvo model, or knowing that it's expensive to move prices a lot. That's the Rodenberg idea. In both of those models, the firms are looking forward. The past is irrelevant to them. Okay, and that's an important problem, because you try to fit this model with econometrics to the data, and the data tell us that inflation is very, very persistent. Okay, so this is an old paper, which is a classic. These two guys, one of whom I went to graduate school with, he actually shows that there's so much persistence in inflation, there's so much backward-looking dependence, it is hard to make that consistent with the pure Calvo or Rodenberg model. So we have to cheat. So how do you cheat? Anybody have an idea? Yeah. Yeah, exactly. So economists are very creative, right? So you basically say that some economists, some of our price setters understand what's going on, and the others are maybe not paying attention. They're distracted by the same guy calling on the phone, and they say, okay, well, I raised my prices by 2% last period, I'm just going to raise them by 2% again. Okay, so that's called backward-looking, or if you like, indexation. You can call it all sorts of things, but it means basically we're going to assume that some of the agents are not clever enough to do what we're doing for reasons, maybe because the life is complex, or maybe they have a contract, but you have to have some arbitrary additional assumption to make the data sing for you. Because in this model, inflation is too jumpy. Okay? And, I mean, again, the model is brilliant because it helps us explain the 1970s when people had really stubborn expectations of the future, and they really believed inflation was going to last, not just in America, but also in Germany. Okay? People just had this gut feeling that inflation was not coming down, so firms were actually, pushing the limit. But now we have a situation where inflation is very low, firms aren't raising prices. We think maybe it's because of cost shocks, maybe the China shock, whatever. But we still have a problem getting the econometrics, which you're all good at, to work. So the solution, the stopgap solution, is to assume some form of indexation for some fraction of the workers. Okay? And that works. It actually works. It works so well, it's embarrassing. So it's like this cheat that helps us go both forward and backward. Okay? So this is the critique of the new Keynesian Phillips curve, and it's in the form that I showed you. Okay? The Calvo assumption and the Rodenberg assumption, the firms are just a bit too good at what they do. Okay, so in fact, we observe firms that we saw them in the data, and I'm going to show you them again. Firms don't always change prices when inflation is rising. Sometimes they cut prices. Okay, so what matters is the average. Okay, so another way of thinking about this is a rule of thumb. Okay, so some of the firms may be randomly selected, just go for the rule of thumb because they got another phone call or they have a conference to go to or, sales meeting or something. Okay, so again, this is ad hoc. This is not what macroeconomics should be always about. You always have to move forward. So can we do better than this? The cheap fix. Okay, so I'm not preaching, I'm just telling you the way it is. It's a great way of thinking about inflation. It's worked, but it's subject to a lot of issues, and this is one of them. I've already said some of the others. I'm not done yet. Another problem with this model is that they don't pay attention to the capital stock. So, and again, I'm not teaching the entire setup, but if you read Galley's book, they kind of put capital under the rug. And in a country like Germany, where capital intensity is pretty high, it's kind of hard to ignore the capital. It's got to come from somewhere. So you really want to think about the representative household, not just deciding Chinese versus Döner, but also putting away capital that will expand the capital stock in the future. Because we can look at this in terms of fluctuations. Sure, it makes sense from quarter to quarter, but if you're thinking about the next 5 years, there may be some aggregate effects. Think of the capacity constraints that make marginal cost rise. If you invest a lot, marginal costs won't rise so much. Okay, so it's just one of the areas of current research is how to incorporate investment into the firm's problem. Now, I think we have a good way of doing this. Remember how we had the taxi company renting the capital from the household. So the household was doing all the savings, and it was renting the capital to the companies, and the companies were using the capital and then returning it to the households. So that's the right way to do it. You don't want to have the firm having random price changes and also dealing with investment. And Lutz Weinke has made some very important progress in that area in his research, but it's probably a pretty tricky way to model it. But you want to have capital. I think that's a good point. It's nice to have this modeling of price rigidity, but you need to think about capacity constraints. Okay, and one of the most interesting macro effects we know about is that economies that are doing well are investing a lot. We call that the multiplier accelerator effect. Paul Samuelson wrote about it in the 1940s. You see it in China today. You see it China coming down. China's investment rate is slowing down, and it's causing the economy to slow down. And we think that's because of the aggregate demand effects, but we also know at the same time, the accelerator effect will also affect the accumulation of capital, which will affect aggregate supply. Okay, so the ability of China to produce in 2 to 5 years will be a function of how much it continues to invest between now and 5 years from now, because the Chinese have a huge savings rate. It's like 40+% of GDP. It's a lot of investment. So, if the rate of growth, the rate of GDP growth falls, that's also going to have an effect on the future aggregate supply of that country. Lastly, and you've taken this, if you've taken my course or Professor Weinke's course, you know what the Lucas critique is. So I think it's pretty obvious that the Lucas critique applies to the Calvo setup, because this ferry is an invention, okay? And if the rate of inflation is high, I can't imagine the ferry would have the same behavior that she would have, if it's a woman, would have if the inflation rate is low. So in other words, if the government tries to change policy that raises the inflation rate, that will change the ability or the interest of firms, whatever it's caused by, to change their prices. And therefore, it's probably not appropriate to assume that it's a constant, fundamental deep parameter in the model. Okay? So this is kind of like embarrassing, but it works. So we're looking under this light post because there's a lot of light there, but that may not be where the key is. Right? So it's a classic issue with us. Okay? So think about that. Think about that tonight. So now I'm going to give you some data. I want to show you some interesting stuff about Germany. So this is Germany in the Great Recession. So who says inflation can't be negative? It certainly can. Now remember, this inflation rate is the average of possibly tens of thousands, if not hundreds of thousands of prices. Okay, so what do we know about averages? Kind of conceals the variation. So during this Great Recession, some firms were cutting prices 30, 40% in those months. Others were actually raising their prices. And I'll show that. I'll show that to you in a second. So, you think of inflation. Inflation is the rate of change of an average, a big average. So it's like a tanker. It's really hard to get that thing going, and you can't learn much about individual prices by looking at the inflation rate. But you can learn about the incentives, you as a worker, to work harder or less hard if your wages aren't keeping up with this price index. Okay, so let me document that a little bit. So this is the inflation rate. So normally we use like a line chart, and this is just a certain interval, monthly, year-on-year. It's in German. Year-on-year rates of change. So you have this. You can kind of I think it's actually seasonally adjusted data, but you wouldn't see seasonals anyway if you use 12-month differences. Okay, but you can see big negative. It's a negative rate of inflation of year on year as a result of this great recession. It came really quickly. Okay, so this is this period of stress in mid-2009 was because a lot of retailers just weren't moving the goods, but also because wholesalers weren't moving the goods and they were cutting prices, and a lot of what Germany imports was coming from countries that were in distress. Now, of course, in the meantime, you see it's changed. Now, let's look at January 2011. Okay, so this is another kind of crisis period. This is like around the European sovereign debt crisis. Now, again, if you don't know these words in German, you've been living here a while, you should learn them. Okay, you should learn a little German. Schmuck. Now, if you say English, you're a Schmuck, that means something different. But Schmuck in German is jewelry. Okay, so during this month, the price of jewelry took a nosedive, 30%, right? This is a big category, okay? And on the other hand, if you were buying some lettuce, Kopf bzw. Eisbergsalat, you have a price increase of more than 30% in that month. So prices are moving a lot. This is in a distressed time, okay? And I don't know about you, but I like Gurken. Not just the ones from the Spreewald. The price of pickles was falling by almost 30% in that month. So, I mean, now you're going to say, how do they get these prices? These are like averages of lots of different samplings in stores. So it's not just one price, one store trying to get rid of their Gurken. This is like many stores trying to get rid of their pickles. Okay, so you can see that the whole, again, some of you are going to ask, what is a camcorder? Okay, so we don't have those anymore. Right? So there are goods that disappear from the index because people don't buy them anymore. But that's not a problem. We can deal with those issues. We can use chain indexes. Okay, but it's like saying in my Calvo problem before, the Galley version, if some part of this interval just disappears or gets replaced by something new. So this is an interesting issue for a lot of people. How do you deal with that if new goods come online? How does that affect the inflation rate? Okay, so these are exciting areas if you like this kind of stuff. This is exciting. Okay, so here's the most recent. A lot of you are concerned about the rents in Berlin. Okay, well, that's showing up in this number. So after many years of inflation rate that Germans like, under 2%, we're now getting a little bit of, this is up to June of 18. You can see a spike in inflation to 2.2%. Okay, and it seems to be hovering a bit over 2%. Now, if you're in Berlin, it's much higher because rents have gone up a lot. Okay, so what am I talking about? Rent is a very important component of the CPI. It's not like every good has measure 0 in the price index. It's not like the formula I had. The measure of housing is 32% in the German CPI. So once the price of real estate starts rising, the price of new apartments starts rising, you're going to see more inflation. especially in this city. You also see that, okay, so those of you who don't know German, gotta learn these words, they're important. Wohnen, it's like, how much does it cost to live somewhere? Verkehr, and I'm talking about travel, not the other kind of Verkehr. I'm talking about travel, taking the bus, taking the train, taking the taxi, etc. And you've got Freizeit, Unterhaltung, Kultur. Okay, so that's like going to the movies, going to the theater. Then you've got food and related products, alcohol-free products. The alcohol comes in a different area. It's up here, alcohol and tobacco. Okay, so you can see that these weights, and they differ across European countries. If you go to the ECB website, you can actually get this picture for a lot of different countries. So the Portuguese have a different, so they consume fewer cars and maybe a bit more clothes than the Germans do, and the French also, but it's very similar, okay? But those individual components are all driving inflation. So even now, there's a lot of dispersion. So I gave you this distress situation. These are much smaller deviations, but you can see that, onions and garlic, 38% plus in December 2018. So this is really recent data. I don't know if you noticed that. I didn't, okay? Because the mass of garlic cloves that I buy in a month is pretty small. But you can also see that airplane tickets dropped by 5%, or price of grapes for some strange reason. Maybe they had a big harvest in Chile. So, all these things coming together, we're talking about trying to track this average tendency. We need to really work hard to capture the different types of goods involved here. Some charged by firms in competitive markets, and some charged by firms in very non-competitive markets. Okay, so the last part, I'm going to signal something we're going to do next time. I'm going to try to indicate probably one of the most fruitful ways of going forward to capture this persistence in the data that we see in inflation, try to maintain some dispersion of prices like we see in the data, like we just saw, and not have this Calvo ferry. We may need a different type of ferry. So we might need a Calvo-Fisher ferry. Okay, so the idea behind this innovation in the literature goes back to Stan Fisher in 1976, which says that what matters is not the ability to change the price, but it's when you chose the optimal price. Okay, so you can think of, Calvo is about rigid price setting. You could think about rigid access to information to make you want to change your price. So it's a different tack, okay? So the author of that book that I've assigned to you, one of my heroes, Jean-Pascal Benassi, anticipated this very important paper by Greg Mankiw and Ricardo Reis in 2002 QJE, which actually thinks of rigid information as being the problem. So firms have a Calvo ferry, but it's not forcing them to keep the same price until they can change it again. It's forcing them to keep the same information that they wrote down their price plan with. Okay, so you have to think hard about this, but there's a big difference. In the Calvo problem, you're allowed to set your price, and you're not allowed to change it until the ferry comes. In the alternative set, you could imagine being able to set any price you want, but you've got to get the information. You've got to get your marketing department to find out what the right price is. And if you're not paying attention because you're trying to make a profit, you're trying to do business, not forecast inflation, then you're only going to sporadically get the update you would need to set the right price. So this model works much better than the classic model. And that's what Greg Mankiw show in their paper, at least in my opinion. I think I'll show you the pictures in a second. But it has a lot of similarity to what Robert Lucas wrote down in his way of thinking back in the 1970s. When I first came to Humboldt, I used to teach that model. I don't teach it anymore, but if you want, I can teach it to you. I have to have a different course. The idea is simply, in Lucas's idea, firms can set whatever price they want, but they don't have the information. Okay, they live on an island, or they're somehow separated from other information sources, so they're always kind of in the dark. And that sounds to me a lot like what we have today. Okay, firms, either they don't, they're too busy maximizing profits, occasionally they look at the newspapers and see what's going on, and they, in a sense, it's the same idea. So Lucas, almost 40 years ago, was thinking about why inflation reacts so sluggishly to changes in aggregate demand. His idea was it takes time for people to figure it out, and they're just not paying attention. It's kind of a shock to them. Okay? This is the same guy that invented the Lucas critique in the 1970s, in 1976. Okay, so let me see if I can try to give a picture representation. So remember, the Calvo idea is, in some point in the past, you set a price and you're still stuck. You're stuck in your decision because the ferry hasn't visited you. Okay, that would imply that some firms are stuck in a very long duration price, and some were lucky and they were able to change. Okay, and the price index is just a cut. It's just an average of those prices. The sticky information idea would be that, some of us, we're all basically setting our ideal price with pure flexibility, but with different information sets. And for those firms that were in T minus J, they were saying, okay, I'm going to set that price in that period, I'm going to set that price in that period, but then I'm not allowed to update my plan until I get to update my information. And if I do, then I may change everything. Okay, but it has a different effect, because what matters for the price we observe today is basically the information sets in the past that were maybe pretty lousy right now, but the people are just kind of stuck in their information from back then. So it's not that they're stuck in the same price, they're stuck in the information set that motivated them at some previous period to set the current price. Okay, so I claim this was kind of discovered by Benassi, but the great recognition of the profession goes to Mankiw and Rees because they got it in the QJE. Great idea. It also implies persistence. Okay, so it has the same flavor as Calvo, except it doesn't have this front loading. Firms aren't like, if they get a chance to change the price, they're going to anticipate everything that's coming up in the next 30 years because they may not get to change again. But in fact, what's happening now is that firms get stuck in a state of ignorance in some sense. And maybe it's because it's just too costly. It's just too costly to do the market research because it is costly. Even today with internet, it's very costly to know what your customers are. I just saw a very interesting talk at the DIW about marketing in the digital age. And it turns out that these firms that are brokers, the data is the gold of the 21st century, they say. So you can buy data, you can buy cookie information and all that stuff. They don't even know the gender of these people. They claim to be men, but they're not, because they look at their Facebook accounts and they're actually female, or vice versa. So, we don't know everything, and nobody knows everything. So, again, this is, to me, a very plausible way of thinking about this. So if you're interested in this, read the Benassi book. It's very, very concise. You can also use this model to think of wage rigidities, which sounds to me like collective bargaining. Firms and workers get together at random intervals to discuss the future, but once they've set that wage path, they can't change it. Okay, it's a contract. Okay, and it's a Calvo. You've still got the ferry. It's just an info ferry. It's not a price ferry anymore. Okay, so again, if you like that kind of stuff, it is kind of interesting to think about. And I'm not going to go into more details, but you end up getting a similar type of setup, like I showed you before. Now, if you set this up, you have to close the model. You have to put some aggregate demand in there. So the strategy chosen by Mankiw and Rees and Benassi is just to have money supply as aggregate demand. So it's no interest rates, no Taylor rule. Basically, it's just the government squirts some money into the system and sees what happens. So it's like again going back to Hume and Cadiz, right? The money comes in, you're in a different information set. You don't know that all this gold is coming in, so you say, I'm going to produce like crazy. Wow, this is real profit for me. But in fact, there's just a lot of gold sloshing around. So when you finally look around and say, I have to update my information set, you've already made kind of a mistake. Okay, so if you set up a model with impulse response analysis, you actually get something in this Benassi, Mankiw, Rees model that looks a lot like what we think the data tell us. So if you do a structural VAR under normal conditions, a monetary shock does look more like this than it does like a pure Calvo model. So in Mankiw, Rees, they actually do a comparison of the Calvo model, a naive sort of moving average type of model, and they show they're quite different outcomes. Okay, sticky prices versus sticky information. Okay, so it's a possible solution to this persistence issue, and you know, some mixture of this with rule of thumb pricing is probably the way to go. So if you go to a central bank to work, you'll probably be doing one of these types of modeling setups. Okay, so I've kept you a long time. I hope it was entertaining at least. We talked about Chinese food, doner, bananas, and Calvo and Rodenberg and Mankiw and Benassi and Ricardo Rees. So have a nice week, and next week is the end, right? So enjoy it. See you later.